Today we are going to do important question of chapter 1. I am taking exemplar questions first. So first question is f is from R to R and the function is defined by x upon x square plus 1. X is a real number. Remember, whenever there is domain R and it is a quadratic function, so this is not 1 1. And if codomain is R and it is a quadratic function, then it is not onto. Okay, for quadratic function only. If domain is R, it's not 1 1. If codomain is R, it is not 1 2. How will we show it? So first case, f is not 1 1. So for 1 1 we are checking. So what are you taking? Let x1, x2 belongs to R. So suppose that their images are same. Means f of x1 is equal to f of x2. So x1 upon x1 square plus 1 is equal to x2 upon x2 square plus 1. So cross multiply x1 into x2 square plus 1 is equal to x2 into x1 square plus 1. So this is x1 x2 square plus x1. Bring those terms this side. X2 x1 square minus x2. That is equal to 0. Now, from this term and this term, take x1 and x2 common. So what are you getting? x2 minus x1 na? Plus x1 minus x2. So x1 minus x2, can you make common? So this will be 1. From here it is coming 1 and from here it is coming minus x1 x2. Why? Because x2 minus x1 will change to this, giving you this minus, right, is equal to 0. So when the product of two terms is 0, then either x1 is equal to x2, this is giving you this, or 1 minus x1 x2 is equal to 0. So x1 x2 is equal to 1 or x1 is equal to 1 by x2. So here you are getting that x1 is equal to x2 and x1 is equal to 1 by x2. Means for x1, you are getting two images, f of x2 and f of 1 by x2 also for f of x1. Right? So then f is not on 1 1. Not 1 1. So if they ask you, how can we make it 1 1? What will you have to remove one option, huh? So remove this option. What can you say? Either change domain to n it, right? If domain is n, then it is 1 1. Clear? Because if it is R positive or something, it will remain not 1 1. Next come to onto. For onto, what we will do? F onto. We want to show that it is not onto. So let y is equal to x upon x square plus 1. Cross multiply. X square plus 1 plus y, that is equal to x. So this is x square y minus x plus y is equal to 0, which is a quadratic in x, right? So if I want to find x from here, there is another way also. But if I want using the discriminant method, it will be a is equal to y, b is equal to minus 1, c is equal to y. So put minus b. So 1 plus minus b square, 1 minus 4ac by 2a. Y can't be 0, na? But here codomain is y belongs to R, na? From here. And R contains 0. Or you can say 1 minus 4y square should be positive. Or 4y square, 1 is greater than 4y square, or 4y square is less than 1, or y should lie between minus 1 by 2 to plus 1 by 2, which is again a contradiction to this. So f is not onto. As codomain range is what? Range of this is minus 1 by 2 to 1 by 2 minus 0. but codomain is R. As range is a subset of codomain, therefore it is not onto. Clear? This is first question. Neither one. Remember, you have to do this way only. Then the second question is, write the domain of the real value function when this is this. If d is a 25 minus x square should be positive, right now? So 25 minus x square is positive. So you can say 25 is greater than x square, or x square lies less than 25. So x lies between minus 5 to 5. What I am using is x square less than equal to a square, or mod of x less than equal to a. For both, x lies between minus a to a. This is the result. And if it is x square, x mod of x is greater than equal to a, or x square is greater than equal to a square. For both, it is x is greater than equal to a, or x is less than equal to minus a. Remember these results. Very important results. So this can give you the domain. If you want the range, for the range, if you put minus 5 to 0 over here, what are you getting? 0, na? So its range will be 0 to 5. Because for all negative values, it's giving you the positive value only. Remember, for codomain square root of this square root function, the range is never negative. Next, find the range of this. So first take 2 minus cos x. You have to find this. So cos x lies between minus 1 to 1. I need minus cos x. So if I multiply, inequality changes. So this will become 1 greater than this. Then I have to add 2 minus cos x. So add 2 to all. So this will be 3 and this will be 1. Now I have to take the reciprocal. Now we know that if 2 is less than 3, but 1 by 2 is greater than 1 by 3, right now? So if I'll take the reciprocal, again inequality will change. So this will be less than equal to 2 minus cos x less than equal to 1 by 1 will remain 1. So its range is 1 by 2 to 1. Clear? Now these are the exemplar questions which I have taken. Next is quadratic questions. Quadratic questions means you have a quadratic equation which you have to question is fx is 9x square plus 6x minus 5. It can be any quadratic equation over there. F is defined from r plus 2 5 minus 5 to infinity. Now I'll show you here also that if it is r to r, then how it is not on 2 and 1 1. I'll show you both the conditions, right? So first I am taking this r, that my domain is r. I'll change it to r plus. How you can check it? So this is let x1, x2 belongs to r. If it is given, then you will write r plus. Remember, if given is this, then no need to worry. You will just write r plus. But as I am showing you with r, so I am writing r. Clear? So this is, wait. So this is f of x1. I am taking r. F of x1, let the image is same. So that will be 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. 5 cancel, bring all the terms this side. 9x1 square minus x2 square plus 6x1 minus x2 is equal to 0. Now, if I write this as a plus b, a minus b, this will be the terms now. So I am taking x1 minus x2 common. So this is 9x1 plus 9x2 plus 6 is equal to 0. So Product of two terms is 0. So either x1 minus x2 is equal to 0, or 9x1 plus 9x2 plus 6 is equal to 0. From here, I am getting x1 is equal to x2. And from here, I'll get x1 is equal to minus 9x2 plus 6 by 9. Right? So if it is a real number, so this is possible, na? Negative of the number. Fraction is okay because it's a real. But if negative is there, so it is not onto because I have taken R. So if they ask you how to make it 1, 1, what will you say? Making R positive. That's why here R positive is given to make it 1, 1. That's why they have asked, show that it is bijection. Clear? So if R is given, what will you say? To make it R1, change R to R plus. Clear? So here as R plus is given, so it is 1, 1. Clear? So what will you write over here? Rejected. Rejected as x1 belongs to R plus. I have shown you earlier for R, now as R plus is given. So this is this. This is for, therefore F is 1, 1. Clear? Don't cancel the terms. Remember, don't do this mistake. N of x1 plus x2, x1 minus x2 is equal to 6 of x1 minus x2 and cancel this. No, no, no. You can't do this. This is wrong. Conceptually, it is wrong because you are just vanishing one of the solution. You can't cancel the terms in algebraic expression like this. Next one is on to. For on to, I have y is equal to 9x square plus 6x minus 5. Make it a perfect square. So what I am doing, I am bringing 5 to this side and making this as perfect square. So 3x square plus 2a. B should be what? So that I am getting this 6x. So 2 into 3x is already 6x now. So I am multiplying it by 1. So what do I need to do? Add 1, subtract 1 to make it perfect square. So that will be 3x plus 1 whole square minus 1. So can I take minus 1 this side? So this will become y plus 6 now. If I take minus 1 to that side. So 3x plus 1 will be positive square root of y plus 6 because x belongs to R positive. I can't take negative over here. So 3x will be y plus 6 minus 1. So x will be, this 3 will come down now. Right? Now, if this is R, then y plus 6 minus 1. Y plus 6, you can say this is as x is R positive. First remember this. X is R positive now. Means this should be greater than or equal to 0. Right now? I can't take negative number. So this whole numerator should be positive. So from here, what I am getting? Y plus 6 is greater than 1, or y plus 6, if I remove the square root, that is also greater than 1. So y is greater than minus 5 now. Right? But if here it is R, so my range is coming minus 5 to infinity. But my codomain is R, so it is not on to. But if it is already given like this, then it is on to. If it is R over here, what will you say? If we change codomain from R to this, it is on to. If they ask you what modification can we make to make it onto, and R is given over here, what will you say? That if we change codomain from R2 to this minus 5 to infinity, we will get onto. Okay? And here what will you write? As it is already R plus 2 minus 5 to infinity, as range is equal to codomain, therefore F is onto. Clear? Then next, you can check all the quadratic functions like this only. All the quadratic functions will be solved like this only by completing the square. If you have any doubt, you can send me the question. I'll send you the solution. Next one is equivalence relation. Equivalence relation, remember the important questions are mod of x minus y is a multiple or divisor, multiple or divisor of 2, 3, 4, 7, कुछ भी, it can be any number it can be. This is one of the question for um, this equivalence relation. Then there is this inequality, x is less than equal to y square and x is less than equal to y cube. These two inequalities are important, and this I have shown in my video of relations and function. If you check, it's given over there. Remember, for transitivity, for reflexive, for both reflexive, you will take the fractional number. A is equal to 1 by 2. So a is not less than equal to a square. Now why? Because this is 1 by 2 and this is 1 by 4. So 1 by 2 is not less than equal, and for cube 1 by 2 is not less than equal to 1 by 8. For symmetric 1, 2 you can show for both. Symmetric 1, 2 is an element of R, but 2, 1 is not an element of R. Okay? For transitivity you will take 5, 3 and 2 over here, and here 10, 3 and 2. How? 5 is less than equal to 9 and 3 is less than equal to 4, but 5 is not less than equal to 4. So this is not transitive. And here 10 is less than equal to 27, 3 is less than equal to 8, but 10 is not less than equal to 8. So these are the three questions from NCERT which are important from the point of view of equivalence relation. Clear? It can be multiple or divisor of anything, and remember, you have to, for the mode, you have to take plus minus in transitive as well. Symmetric you don't need to take plus minus, but transitive, when you add a plus b, p plus c, then you have to do this. Is it clear? Then there is this, when n cross n questions. The question is, n is denote the set of natural number and r is defined from n cross n to n cross n by the relation AD into B plus C is equal to BC into A plus D. So how will you do this question for reflexive? Remember, here the element, single element is AB only. So I'll say AB related to AB. But you need to remember this also, because AB related to CD, then only this is true, na? So to mark this, just with the pencil, write this as CB so that you take this in the order. This is your rough mark which you will erase later. So this is AD. In place of D is B over there. So B is B, C is A. That is equal to here BC. B is B, C is A, and A plus D. D is B over here, which is true. Therefore, R is reflexive. Then symmetric. For symmetric, what will you do? If AB related to CD, then AD into B plus C is equal to BC into A plus D. This is given. You have to show CD related to AB. So this is your rough work. A, B, C, D, right? With the pencil, you will write this so that your calculation doesn't go wrong. So AD, A is C, D is B, CB, A plus D. A plus D is, sorry, AD into B plus C. B is D over here and C is A, right? That is equal to what? BC. B is D over here. C is A over here. That is equal to, sorry, not equal to. A plus D, right? So from here, if I just exchange them, BC into A plus D, that is equal to AD into B plus C. And write in the different order, CB A plus D is equal to DA C plus B. Any problem? No, na? D plus A. So you can say CD related to AB. Clear? From here, I have got the idea that what do I need. Remember, this is the only way to do these questions. Otherwise, in the paper, you will get nervous and you write down the wrong things. Next, for transitive. What is transitive? AB related to CD, CD related to EF. Then you have to show AB related to EF. Right now? So, for AB related to EF, what do we need to show again? C and D. This is your pencil work. So, AD, matlab AF into B plus E, C, which is C, is equal to BC, BC into A plus D. This is you have to show, right? So, let us start from here. AD into B plus C is equal to BC into A plus D. And here A AD into B plus C is equal to BC BC into A plus D. Right. Now, one of the best thing over from here is just to change it into fraction and then bring into the original form. Otherwise, it will become very difficult. So what I am doing is I am writing it as B plus C by BC is equal to A plus D by AD. So this is 1 by C plus 1 by B is equal to 1 by D plus 1 by A, or 1 by B minus 1 by A is equal to 1 by D minus 1 by A. Same here. D plus E by ED is equal to E plus F by EF. A plus, sorry. C na, sorry. This is BC. BC is EF into AD into B plus C. AD into B plus C is equal to BC into A plus D. So this is C. So C plus F upon CF. So I am getting from here 1 plus D plus 1 plus E is equal to 1 plus F plus 1 plus C. So this is 1 by D minus 1 by C is equal to 1 by F minus 1 by E. So from here, if you compare this and this, what I am getting? 1 by B minus 1 by A is equal to 1 by F minus 1 by E. Take the LCM and again exchange them. So this is 1 by B because I need so from here I am getting 1 by B plus 1 by E is equal to 1 by F plus 1 by A. So that is E plus B by EF is equal to A plus F by AF. B, EB, AF. So am I getting the answer? AF into B plus E is equal to BE into A plus F. Therefore, R is transitive. Clear? So as last statement, as R is reflexive, symmetric and transitive, therefore it is an equivalence relation. Okay. So this is the one of the question which is important. Again, I am telling you, please check this mode question or simple difference question so that you can do these questions. Clear? Thank you.